Assalamualaikum warahmatullahi taala wabarakatuh. Salam sejahtera. Selamat pagi. So supposedly that this topic which is covered yesterday, but I'm not feeling well yesterday. So today I'm cover it. So anyway, I record it today or tomorrow or next year. It is not concern to you because you are watching YouTube, right? So there's no problem as long as you get the lesson, right? So continue on our lesson on last week, which is we are already covered on lab number 1 and lab number 2, right? So today we will do some assembly and do some animation. Okay, we will do some assembly and do some animation. Last time we are using, if you are open SolidWorks, last time we are using a part to create a part, and now we are using assembly to assemble all the part that we have created in the parts UI, okay, user interface. So we will use assembly here. If you go to the SolidWorks, software, go to the new file here, just press it there and new pop-up window that came up. And then press the assembly and press OK. Wait a little second, and then this is new assembly interface. This is new assembly interface. Okay, right now how to import all your component that you have designed in a part section. You can press browse here and allocate where you have saved the part itself. So for me, I'm saving, and if I'm not mistaken, SolidWorks and the teaching and this code and assembly. So start with part number one. So this is my part number one. Okay, and another component, insert component, not insert a new part. If you are insert new part, they are insert the new part. So you need to you need to sketch, and you need to form a 3D inside the assembly. But in this case, we have already our part, so we only insert a components, insert component. Okay, and browse again, part number 2, we put it here, anywhere lah, you can put anywhere. So another component, which is our shaft, part number 3, which is we put it here, and then we just import all the part that we have designed from our previous week. Okay, and now how to make them, how to assemble them together. We are using a mat function here. Look at the paper clip there. There's a mat function. In the mat function there, we have coincident, parallel, perpendicular, tangent, eccentric. For example, coincident. What is the use of coincident? Let me press a coincident. For example, you need to match between this point and this point at one point, so they will meet together. For example, let me press here this point and this point, so they will meet together. Okay, that is the use of coincidence, where a point meet a point. Okay, but we don't need a point meet point for our cases here. Just let you know how to use the coincidence. How about the parallel? If you want to use parallel, let's press parallel here, parallel here. So it goes coincident, but you can go to parallel there. If you go parallel there, it show you a distance there. You can control with distance of the parallel features of map. Okay. If you want a 0, you can go with 0. If you press 0 and click there, it shows the same function as a coincident, but you are using a distance there. Okay, instead of 0, if you want 1, not 1, 1 meter banyak sangat. 1 mm for example. So 1 mm. Okay, so if you look, if you look, the distance between here and here is 1 mm. Okay, it has a 1 mm. Okay, if I look at from the top, it is not line. Okay, it is 1 mm. So this is how you use parallel. How about the perpendicular? You can imagine lah, if you are using a perpendicular, exactly you want to perpendicular between this component and this component. For example, pressing this component, pressing perpendicular first, this component and these faces and these faces. Want it perpendicular for 90 degree. What is not 90 degree? It is already 90 degree. Okay, it is already 90 degree. Example, pull this and this. Okay, go perpendicular with 90. You can go with 90 degree here. 90 degree, put it as a 90. So it go 90 degree. 90 degree between this face and this face. You must know which faces you are clicking. Then you want to rotate triangle. Okay. And how about the lock? The lock one is you don't want your part to move. You don't want the part is to move. For example, the piece part here, you don't want it to move when you're simulation it, or you want to animate, or you want to do some motion study analysis. So you need to lock one of the part. For example, here I'm locking this one. Locking this one. So it is locked between what and what point and what point. This lock and this lock. So the position between this and this cannot be moved. Okay, that is how you to lock between part. Okay, and how about the concentric? Concentric, it is a easy. It is cylinder and cylinder. Okay, you press on the face of the cylinder and the inside of the cylinder, so it will move. It will be moved. Okay, press OK then. To make it align, you can imagine how to make it align. Press under there, under there, so it will align together. Okay, and now I want to match this here and this here. Can we match it? No, I cannot match it because I already locked it. So how to remove that lock? How to remove that lock? Go to that match on the tree here, on the right, on the left hand side. Cari lock punya sign, delete. Press delete and yes. So that lock is already removed. So go mat again and press a standard mat or coincident, for example, this face and this face, you need to align them together. Press OK. This here and here, you need to align. No, not that one. Mat between this face and this face. Then uh, still not made it enough. Here and here. So it has a complete, right? It is still not complete because we have wrongly made between the top there and the shaft and at the bottom there. So we need to correct them by deleting the appropriate coincidence. I think this one. We need to delete it and meld it again. Bottom of the shaft and the bottom of here. Right click, which is okay. So then we already made it. We have made all the components. Okay, we already made all the components. So you see on the assembly tab there, we have insert component, we have map, we have component preview window. We can also linear component pattern. We can copy all these components. We have smart fastener. We can move the component either linear or rotate. We can show hidden component. There's a lot more. Here is we can explode the view. Explode the view. Let's press it. So we can have a new tree there. We can have a new tree there. To use this one, which is to explode your component, so that you can have an animation during presentation. For example, you want to present all the component to assemble together. This is how you do it. Okay. For example, you done all the component in a perfect match. Okay, you need a perfect match of your component, and then or of your assembly, and then press explode the view, and then came up with this property manager. Then under there we have export features. Then remove your cursor to the component and press save. Okay, and then you can see the arrow there. From here it is important which part is moving first. It is important. So for example, I'm moving the shaft first. In second, move my cursor to the second part, then slide it upward. Okay, is right there. Okay, and that's it. I'm pressing OK. So I have explode view, right? I have explode view, and then I move my cursor to the property manager there. At the top of assemble title, then right click there and go to animation of collapse. Animate of collapse. So it will animate your explode view just now, right? Okay. So there we have animator controller, animation controller that you can go playback. Macam ini dia rotate atas dan bawah kan. Kalau you press this one, dia akan buat macam ni lah. Kalau dia on playback on normal, dia hanya sekali saja. Right, settle. Kalau dia macam ini, and play it again, dia macam dia repeat it again. Kalau you go back on forward, reciprocate, keluar masuk lah macam tu. So you can slow it down, you can move it fast. It depends on your requirement. If you have a lot of component, you can move it faster. How to save your animation? We have save animation there. You can just simply save as a type of, it is either AVI or BMP. I think AVI is good enough. And we have image size. You can use custom aspect ratio. the square format, 4:3 format, or 16:9 format. It depends on you and where you save it. Okay, for me, I don't need to save it because it is require a space. Okay, if you have a lot of component that require a lot of space of your hard disk, so I don't think I want to save it. But 8 seconds, it is enough frame per second. See there, you have 8 seconds is not long enough, but it is good for your presentation on your slide if you want to show your presentation on the animation itself. Okay, you can save it and you can play it on the Canva, or you can play it on your PowerPoint later on, so no problem. You can save your animation. For me, I don't want to save it, so that's it. So I have covered on how to assembly. I have covered on how to make animation. It is not motion study. It is animation. Animation is different from motion study. Later on, we will study on the motion study, where motion study will make a contact where gravity is present, contact is present. For this one, it is for animation. For animation, the body between component and component, it can be go through. Okay, the component, it can be go through. For motion study, the component between component cannot go through it. It is like it is like a study that uh, a true ataupun a real component. Okay, for example, if you want to drop a ball, so the ball, it is the ball, then the floor, it is the floor, so it will bounce. If you were do some motion study, it will bounce according to your physics properties that you embed in your component. Then for animation, it is not a real study. It is just animation, macam cartoon lah. It can move through wall. It can it can it can it can hidden. Suddenly it can be ignore lah. Macam dia punya komponen tu, dia macam bukan a real component lah. Alright. So we done on the assembly and we done on the animation, and then we will go to the new topic. Just now I just present to you all these kind of topic or subchapter, and we have some exercise there. Do it, uh, do practice how to do it, and that will be beneficial for you when we have some practical exam there. Okay, maybe I came out with this question, we don't know. So do a lot of practices, then we will do some practical exam, then I know that you know how to use a SolidWorks. Okay, and then we go to the gear assembly, sorry, a gear modules. If you look at here, before we want to use a SolidWorks, they need some additional library there. You need some additional library there. If you go to the SolidWorks, let me close it all. Don't save. I don't want to save. Before you further your gear lab session, you need to go to setting there to add a SolidWorks motion and SolidWorks tool library there, so that SolidWorks can do some motion, some mechanical motion for your component or for your assembly, and a SolidWorks toolbox library there. Okay, you need to enable them so that your SolidWorks has that features. For me, pressing how to add that, press that setting on the gear figure there, press add in, and then tick the SolidWorks motion there, tick there, make sure you tick there, and tick another one, SolidWorks toolbox, tick that one, and then press OK. For me, I already tick it. It is once in the lifetime. Once you click it and you forget it, just like me lah. Saya macam dah click, then I don't know how to unable it. Okay, right now I know lah how to disable it using a setting and press add in here. Tick that SolidWorks motion and SolidWorks tool library and press OK. So that's it. You just enabling the toolbox library and the SolidWorks motion. And go back to our lab gears module and see what next. You want us to create a base and a shaft. Okay, create a base and a shaft. Let me create it for you. The little fast. It has how many components? 1, 2, 3. 3 components. Basically, shaft is the same part, so we only have 2 components to sketch or to drawing. So we go with new, and we can go with the part, but I'm not a professional user. I'm a immediate ataupun average user. I know how to make ataupun how to draw component in a faster way. Okay, so I go to the assembly rather than part. I'm pressing OK. So in the assembly, I don't have that component, so I cannot import it directly. So I have to sketch inside the assembly UI, user interface. So the first of all, I need to press this new part, and it goes part 1 assembly 2, which is this assembly 2, and I press it again, new part, so it come part number 2 under assembly 2, under assembly 2. Okay, there. Why I need 2 part? Because in our lab session I need a base and shaft. Another shaft we will copy. Okay, now we will do a part first. So how to draw a part inside assembly user interface? You press the part that you just created, there, and right click, press edit part. See there, press edit part. So dia akan warna biru situ, dia akan highlight warna biru, and drop down the tree and select top plan and sketch. Immediately lah you nampak terus you dalam sketch kan, you boleh guna terus ni. Tadi you tak boleh guna dah. So saya boleh lah start lukis. So I want to see from the top, and then let me see the dimension. They are using inches dimension, so I need to change it to inches. Go back again, inches. So the base is 5 times 4. 5 times 4. Select rectangle. 5 times 4. This is 5 inches. This is 4 inches. So to make it center, using this center line, 2.5, and this center line, 2. Okay, we have a center of rectangle of 5 times 2. Then we not yet with the sketch, not yet with the sketch. Need to draw a circle, right? A circle there, circle with dimension of, what is the dimension? 0.5 inches, two holes. Draw a hole any size at the beginning and any position at the beginning. Press the smart dimension and give it the dimension for the holes 0.5 and the other one is 0.5. Give a correct location of the holes. One is, I think it's 1 inches and the other one is 1.87, if I'm not mistaken. Let me see it again. 1.875. 1.875. Done. We're done with the sketches. Then we can create a 3D. We can create 3D. Go to the features and extrude the profile. How many thickness that we need? 0.5. Here is the thickness, 0.5. And press it OK. Done with the first component. We're done with the first component, and then we exit the mode of edit the first part. This is to exit the mode of exit, the mode to exit the part, the component, and then right click on here, then edit part on the second part. So we need to draw a shaft, right? We need to draw a shaft. Select plan that we desire to sketch, correcting our view, and look at the detail of the shaft. 1.5 long, and the shaft diameter is 0.5 inches. So correcting the dimension and selecting again. Let me correct it. Okay, sketch 3, no problem. Take any location. It is revisable. It is advisable to choose center of your plan and make it a smart dimension there. 5 inches, 0.5 inches, I'm sorry, 0.5 inches, and that's it. Extrude it for 1.5. And I think we need a chamfer. What is the chamfer? 0.0645. We need a chamfer. Chamfer is under there. Chamfer, both sides, 0.6 inches. Right? Degree, done. We're done with second component there. And then we need to map them together, right? This cylinder and this cylinder. Dia tak boleh map. So, how to solve that? For example, if you found this error, you press the mat and you want to mat this shaft inside this hole. You press it, the surface of the cylinder and the inner surface of the cylinder, and then it say that both of the selected components are fixed or fully defined. So any mat created between them will be ignored. Kalau you nak try to mat, dia akan ignore lah. So how to solve that? Untuk this component, you right click ya, you right click, you tengok dia ada float kat sini, which mean this component in fixed position. Okay, kalau saya tekan float, saya tekan balik, dia dalam float lah. Kalau dia tulis kat sini fix, kalau kita nak fixkan dia, kita fixkan dia lah. Okay, so this component in fixed position. Also this component, kita tengok dia pun dalam fixed position. So dalam assembly ni dia dah fix, so dia tak boleh move lah. So either one you need to move. So how to move that? So one of the component need to float. Okay, so for this type of problem, the shaft need to be float. Okay, so we just float it. Okay, then we can move it. So it is moved. Okay, it is moved and done. We need another copy right here. So another copy of the shaft. So we just insert the component. Insert component, which because we already design it, so we don't need a new component here. We just insert a component that we already designed. So browse to the part that we already save it. So where the part that we already save it, we still don't save it here. So how to we need to save it first. To save it first, save all, and here new folder which is under gears. Save, save internally or save externally. So I request ataupun saya advise to use to save externally. Kalau you save externally, which mean part that you lukis tu dia akan save berasingan, instead of kalau you save internally, dia hanya ada assembly punya file saja, dia tak ada dia tak ada part punya file. So you need to save externally. So kat sini you can rename it lah. You boleh rename dia according to your name lah. Kalau part 1 tu you ada part number dia, you put lah part number dia. Kalau part 2 pun ada part number dia, you put lah part number dia. For me, I don't have any part number, so it is enough for me for part 1 and part 2. So it is okay, just okay there. Then I can insert a component that already saved. For example, this is already saved there. Part 1 is our base, part 2 is the shaft. This assembly is this whole pipe assembly. So I need to import part number 2, which is the shaft itself. Okay. Then I make them together. Make this component to here. Okay, and bottom there, here. That's it. That's it. Right? Made. Okay. That's it. Complete our objective here. Figure 2, we are assemble them and we already met them together. And then we need to use some library tool for gear. Okay. For example, in table 1 there, gear 1 say that we have a diametral pitch of 24, number of teeth is 30, face thickness 0.5, bore 0.5, hub, and the hub height. Okay. So not waiting too much, go with the toolbox. You can see the design library there. We have a toolbox here. Nampak macam screw, you press it there. Then another pop-up of library there. Since we are using inches, so press it inches there and find a gear under power transmission. Under there we have a gear folders. Under gears folder we have spur gear, helical gear, internal spur gear. So how to use that gear? For lab session number 4, they are asking us to use the spur gear. Click the spur gear and drag the icon to drawing area. How to use that? Click there, hold your mouse and drag it to the drawing area. There, that you have a gear over there. We have a gear there. And see further on the properties manager, there you have a diameter pitch that need us to go for diameter pitch of 24 for the first gear. Change it to 24. It will be changed, and then number of gear is T is 30 pergi ke 30. Pressure angle is 20. Okay. Face thickness 0.5. Bore and hub 1. Saya kena ingat lah ni. Face thickness is face width 0.5. Hub diameter ataupun hub thickness is 1. So I have so nominal shaft diameter, bore thickness lah, nominal shaft diameter ialah 0.5. Nominal shaft diameter itu ialah bore dia lah. So dah betul dah. Half inches ini. Keyways, ada keyways tak? Dulu ke keyways? Dia minta keyways ke? Tak ada pun. Tapi dekat dia punya sini dia ada keyways. Select keyways. Keyways yang jenis square. No problem. Kita tak ada keyways lah. Sebab kita tak masukkan key, tak perlu keyways lah. So that's it. So press OK. Press OK. Then SolidWorks akan request kat kita. Kita perlu tak pergi yang sama macam tu. Kalau kita tak perlu, just cancel saja. Tekan X. Macam tu. Then we drag again. For gear number 2. Kalau nampak macam gear yang sama kan. Yang tadi kan. Yalah dia macam copy saja yang tadi. So we need to change it. The properties of that second gear. Diameter pitch is still the same. 24. The number of T is 60. And different side is face width, hub style one side, hub diameter is 1. Okay, done. Hub diameter is 1 and the only number of teeth, if I'm not mistaken, number of teeth is 30. Change to 60, right? Yeah. 60. Diameter pitch all is the same. And done. Done the component, and SolidWorks will be suggesting another same with the previous one that we need, that we designed the gear. So just escape, press escape, then we'll cancel it. Then now we need to match it together, right? So the first here is to match it here. Kalau dia macam nampak macam terbalik, you can press it here. So it rotate, press it OK to align them, press it bottom there, and here, press it OK again. And how about the another one? Press it here, here, turning back. Alright, and cylinder to cylinder. Alright, we made it together. If you move it closely, dia akan ada intercept kat sini. Kalau you pasang terus dia tak ada intercept, it is good lah. Kalau dia ada intercept, you need to move them in a better clearance. So how to move them a better clearance? Nampak move component dekat tab atas tu, select dia, cari yang rotate component. Okay, dia ada standard drag kat situ, ada collision detection, ada physical dynamic. You ambil physical dynamic. Sebelum tu you kena standard drag dulu. Sebelum you pergi ke physical dynamic, you ambil standard drag dulu. You move, clearkan dia punya location dia. Dia dah clear. Gear 1 dengan gear 2 dah tak ada overlap, dah tak ada intersection. Then you press on the physical dynamic there. Check between all component. Kita move dia. dia bergerak macam tu lah. So dia akan check physical component lah. Nampak dia macam betul tau. Nampak? Dia akan terkena baru dia bergerak. Instead of you gerakkan gear 1 dan gear 2 terus tiba-tiba bergerak. Tak. Dia macam betul-betul bergerak. Tengok, saya zoom dia. Saya gerakkan gear 1, nampak? Once it touch gear 2 baru dia bergerak. Di situ. That mean you have a proper mat and you have a proper matching of gear. You have a proper mat and you have proper matching of gear. Kalau you punya diameter pitch tak sama, dia akan problem dengan physical dynamic punya rotation ni. Okay? Make sure you pass yang ini dulu, baru you go forward with some motion analysis. Okay? Yang ini dulu. Make sure you can do that in your computer. Okay? You can do that. If you've done that, press OK. Press OK, and that's it. We are already assembled the gear, and now how to do some motion study in that. Kita tengok dia ada ajar tak sini. Okay, dia ada ajar kat sini how to do some motion study. You can go with that, how to do some motion study, but I will teach you also here. If you go at the bottom of the SolidWorks there, you can see my cursor there. Nampak ada tulis kat situ model, ada 3D views, ada motion study kat situ. Ya, you press that one. Kalau dia tak keluar naik terus, you press ada button kat situ. Expand motion manager. Expand dia. Okay, expand dia. Then change the first one. You need to change this animation to motion analysis. Okay, motion analysis. Take motion analysis. After that, change that motion analysis features, and you need to make those component of just like a physical component. Okay, select a contact there. Nampak sini yang macam camshaft dengan some valve there. Select there, nanti properties manager dia akan tunjuk mana benda yang perlu jadi solid bodies. Okay, tak perlu semua lah. Mana yang ada contact saja you select. So for this case is gear first and second gear. Yang tu yang perlu jadi solid bodies. Kalau you ada more than 2 components, you select lah komponen yang akan ada contact kat situ. If you're done with that, press OK. Okay, and then you select gravity. Ada gravity macam apple itu, select gravity. Dia akan tunjuk kat property manager kat sini lah. Dia arah Z. Maksudnya kalau ada gravity, kalau you lepaskan you punya gear ni, dia akan jatuh arah sini lah. Sebab dia ada gravity. So in this case saya nak dia arah Y. So saya klik Y. So Y dia dah tunjuk bawah sini. Saya press OK je lah. Saya nak gravity arah bawah sini. Saya press OK. Number of gravity is 9.81 is normal for Earth gravity. It's okay. Kalau you nak study benda ni dekat bulan, you can change that gravity to gravity number of bulan lah. Dan guna 9.81. Okay. So I'm done with the gravity. And how about the motion itself? Press that motor and select which motor need to rotate. For example, I have a driving motor and driven motor kan. Yang driving saya nak yang small gear. So this is small, akan driving lah. Pada rotation dia pun ada di sini. Dia tulis 100 rpm per second. Saya tak perlu laju, saya perlu 10 saja. And what else? That's it. Press OK. And after that, saya tak nak dia dalam 5 second. Saya nak dia 10 second. Okay. Saya nak dia 10 second di situ. Dan saya calculate lah dia. Calculate dia. Alright. Settle. Settle. Kalau you nampak kenapa terjadi begitu, hilang saya punya motions tadi. Pada awalnya dia ada kat situ. Pada awalnya dia ada. Let me slow down. Kalau saya play balik, dia hilang. Kan? Kalau saya slow down, slow motion kan dia. Saya punya motion tadi ni. Saya tengok kenapa dia hilang. Saya press play. Dia jatuh. Dia jatuh. Kenapa dia jatuh? Maksudnya saya tak properly mat dia. Dia jatuh ikut gravity tu. Dia jatuh. Saya replay again. Play dia. Nampak dia jatuh. Dia jatuh. So how to correct that mistake? So this motion study, it is easy way you delete dia terus lah. Sebab dia tak termasuk, dia tak ada mat kat situ. Dia tulis pun ada 6 redundancy. Maksudnya dia akan problem lah. So how to correct that problem? You press model, you pergi kat model, instead of motion study, you pergi kat model. Then you mat a proper mat. Macam yang tadi, gear second dengan shaft ni jatuh kan, maksudnya dia tak proper mat. Kalau kita pergi dekat mat kat sini, maksudnya second shaft dengan gear ni dia mat together, but that shaft and that base dia tak mat. So saya kena matkan dia. Baru dia tak jatuh ikut gravity. So saya matkan sini dan sini mat together. Check again with the mat. Okay, maksudnya yang orange the shaft dan purple the base, dia ada mat, kemudian concentric. Okay, no problem. Yang itu di situ. Okay. Think sudah siap. Then this motion study, update initial animate stated. Saya tak pasti sama ada dia boleh correct ataupun tidak. Saya tak rasa dia boleh correct sebab dia ada coincident ni dah betulkan dah. Okay, so we need to calculate it back. Coincident ni dah betulkan dah. Dia ada coincident kat bawah ni. Coincident 4. So we can calculate it back. Okay, it is moved now. Last time dia tak move kan, dia jatuh kan sebab kita tak properly mat them. So this time dia properly mat, then we can play it. Okay, kita play dia. Terlalu perlahan, kita stopkan sikit, lajukan sikit. Ambil satu. Play. So, dia boleh play lah kat sini. And dia, ni motion study ni, kalau you ada further analysis on the motion study, you boleh nampak berapa stress yang dihasilkan dekat gear tu. Okay, that one akan terhasil di sini. You nampak ni, dia ada rasa expand. Motion study you ada kat sini. Simulation setup. That one kita akan further. Kita akan belajar lagi nanti. Macam mana nak buat benda tu. Okay, sama juga di sini. You can save it. The motion study. How to save it. Kat sini you ada. Mana kat sini? Stop. Kita stopkan dia dulu. Yang ni nak ubah kamera tau. Camera position. Ni pun kat sini ada animation wizard. Tapi nak save dia kat sini. Dia akan keluar macam sama yang macam tadi. You save saja dia. Macam saya save di sini. 10 second. Kurangkan sikit lah aspect ratio dia. 43. Biar jadi kecil. 43. Okay kot. Dia minta codec. Tak boleh lah. Okay lah tu. Nampak sikit lah. Dia akan rendering. Macam biasa. Kalau you ada very good graphic card macam saya ni, no problem. Kalau dia ada problem graphic card, dia akan lama lah. Macam saya punya PC ni powerful graphic card, so it has no problem. Done with that. So kalau saya pergi dekat, dia save kat mana kan? Gear, dia ada gear. Machine design. Kat sini kot. Mana SolidWorks. Teachings. J gear. Ini. Inilah dia yang you boleh save. So ini dia boleh jadi show off lah dekat you punya presentation. Apa yang you buat dekat capstone nanti tu. Kalau you masukkan dalam gambar kan boleh save. You buat slide kan, you buat slide guna gambar ataupun you buat slide guna PowerPoint. Dua-dua pun boleh present video dalam file format AVI. So you boleh show off lah sikit kan. That's it for our lesson lab number 4. Please do these exercises. Go with sampai animate, you boleh buat motion study untuk rotation of that gear. So the problem that you will face is that you need to find the distance between shaft number 1, shaft number 2 and shaft number 3. So that sebab yang tadi base tu dia bagi size siap-siap. For this one you need to draw a base first, then the gear itself datang nanti. So the hole there where you put that shaft, kat mana location hole tu you kena measure dulu. So how to measure that location of hole, you dah belajar dekat lesson yang saya ajar waktu nak kira redundant train, gear train, riveted gear train. You ada belajar macam mana nak cari center of that shaft. Kat situlah gunanya calculation tu, nak cari kat mana titik ni. Make sure do a lot of exercises on that and do a lot of exercises on this one, so that I know that you are proficient enough how to use a SolidWorks for incoming practical exam. Okay, that's it for today. Thank you again. Assalamualaikum warahmatullahi taala wabarakatuh.